Morning, everybody. I hope you had a nice spring break. Today we're going to start our 30, 60, 90 triangles, which is just the second type of special triangle that I want to take a look at with you guys before we really jump into trig and get an idea of this whole sine, cosine, tangent, what they mean, and all that stuff. So the first triangle that we looked at, just as a reminder, was a 45, 45, 90, and it looked something like this. So we had 45 degrees, a 90-degree angle, and 45 degrees again. And we knew some ratios with this triangle because our angles tell us about the sides opposite. And because these two angles are the same, this is an isosceles triangle, so these two sides were congruent. And what we did was we said, well, this side here, the leg, is going to be called x. We don't know how much it is. Let's just say it's x. Then the other side would also be x. And specifically here, for a 45, 45, 90 triangle, if you work out the Pythagorean theorem a little bit, you find out that the hypotenuse of this triangle will always be x times the square root of 2. So for 45, 45, 90 triangles, we just took that leg and we multiplied it by square root of 2, and that's what gave us our hypotenuse here. Or vice versa, if I gave you the hypotenuse and you wanted a leg out of it, you could just divide by the square root of 2 and you get back to your leg here. Now that's fine, and it's a little bit easier than the 30, 60, 90 triangle. And the reason that it's easier than the 30, 60, 90 triangle is because it really boiled down to, do I multiply by the square root of 2 or do I divide by the square root of 2, depending on what I'm given. But with the 30, 60, 90 triangle, we have 3 different length sides. So we have all kinds of different combinations that we're going to have to work with. So I'm going to do my best here to kind of put this into a perspective that you might be able to see, so that no matter which side you're given, you can some way navigate to all the other sides. So if we look, this could be our 30, 60, 90 triangle right here, something like this. So the smaller angle is going to be the 30-degree one. The larger angle is going to be the 60-degree one. And obviously the one that looks like a right angle is going to be a right angle, 90 degrees. So 30, 60, 90 triangle. Now remember, the angles tell us a little bit about that side that's opposite them. So we need to start understanding what I mean when I say opposite. Which side is opposite the 30 degrees? If you recall, I said when you look for an opposite angle, you can draw a line from that angle all the way out to the other side. So the opposite side to my 30-degree angle would be this one down here. And the opposite side to my 60-degree angle would be this one over here on the left. Remember, that's how we kind of determined what the hypotenuse was when we were doing the Pythagorean theorem, because the hypotenuse is always opposite the 90-degree angle. So once you know what's opposite, that's great, and now we can use our angle measures here to tell us a little bit about this. So if you notice, 30 degrees is a lot smaller than 60 degrees. Which means this side that's opposite the 30 degrees should be the small side of the triangle. 60 degrees is also smaller than 90 degrees, so the side that's opposite the 60 degrees should be like the medium length side. And then lastly, the side that's opposite the 90 degrees, well, 90 degrees is the biggest angle on this triangle, so this should be the big side. And we call that big side, in this case, the hypotenuse, because it's a 90-degree triangle. It's a right triangle. So we have our small side, we have our medium side, we have our big side. Now, if we can figure out a way to relate those, and good news is we do have one, because like I said, this is one of those special triangles. This is one of the ones that kind of comes up fairly frequently, that we know quite well, and it gives us some nice numbers here. So take my word for it for now. I was going to show you how all this stuff was figured out way, way back in class and everything, but for an online class, I think you're more concerned with just, well, how do I do this? So let's figure out how we can do this here. What we're going to do, because this is the smallest side, we're going to call this side x. I have no idea how long it is. It's x, all right? Well, if that side is x, then what we find is the medium side, so it's very similar to the 45, 45, 90 triangle. The medium side is just the same thing that x was, but times the square root of 3 this time. So it's x times the square root of 3 for the medium side. And now if you do your whole Pythagorean theorem thing, a squared plus b squared equals c squared, we end up with x squared plus x times the square root of 3 squared equals c squared, x squared plus x squared. Square root of 3 times square root of 3 is just 3 equals c squared. 3x squared plus 1x squared is 4x squared. And then you take the square root of both sides, and you end up with 2x is going to be our hypotenuse. So the hypotenuse length here, the longest side, is just going to be whatever x was, so my shortest side, but doubled. So this is the form here of this triangle that I'd like you guys to memorize, just like the x root 2x that we had before for the 45, 45, 90. Every single 30, 60, 90 triangle follows this pattern, where if you know the short side, the medium side is just the same thing that the short side is, but times square root of 3, and the hypotenuse is just the same thing that the short side is, but doubled. So I'm going to put that up here in the corner, and we're going to take a look at a couple practice problems and see if we can figure out a little bit of this extra stuff, what this might look like on the worksheet that you will have for practice tomorrow. So here is our 30, 60, 90 triangle. And the first problem that we're going to take a look at, let's make it just a nice quick one here. Let's do 30, 90. Let's say this is 12, and I want to know, well, what is M and N? I want to know those two sides. Well, if you look, this has to be a 30, 60, 90 triangle. I didn't give you that this is 60, but 90 plus 30 is 120. Every triangle adds up to 180. We need 60 more to get there, so this must be 60. Now, one way that you could do this is we could use proportions. So we know some things about proportions. We know that I could write any ratio that I want over here, and because it's similar to the triangle over here, it should be equal to the same proportion on the other one, which is great. And I'll show you how to do that after I show you the quick way, where if you just remember some of these facts, you could work your way through this very, very quickly. For instance, the fact that you might remember here is that the hypotenuse of a 30, 60, 90 triangle is just twice the short side. Remember, hypotenuse is 2 times the short side. So if I look here, this is my hypotenuse. Well, it should be double what the short side is. Where's my short side? Short side is opposite the 30, so it's over here, it's N. What do I have to double to get 12? 6. And then we can take that short side, and we see that the medium side is just the short side times square root of 3. So my medium side here, M, should just be my short side times the square root of 3. And we would be done. We found the two things that we're missing. If we wanted to do this as a proportion, let's say that I wanted to find this N value first. So I could do N over 12. That's the short side over the hypotenuse. And I could set that equal to, in my other one here, the short side over the hypotenuse. Now my x's are going to cancel out, so this leaves me with 1/2. N over 12 equals 1 over 2 when you cancel out your x's. And now to get N all by itself, I want to multiply both sides by 12. So we're going to times both sides by 12. And that cancels out the 12 here. And over here, I get 12 over 2, which is 6. There we go. So we can use proportions to also solve these things. And what you're going to see when we start getting into trig is that these proportions are actually very, very useful. This opposite over hypotenuse, or adjacent over hypotenuse, and we'll get to that stuff when we get to it. But for now, let's try to get some of these facts memorized with how these ratios look, dealing with these square roots all the time. All right, let's take a look at another one. And see if we can make some sense of it. All right, so let's do one of these triangles. So here we have 30 degrees, M, and this is my right angle this time. And they gave us this side here is 6 times the square root of 3. And I know this is not a very, very nice triangle. Maybe I'll make it a little bit nicer here. Go like that. There we go. So in this case, what side was I given? Was I given the short side, the medium side, or the long side? Well, it looks to me, since this is 30 degrees, it looks like I was given the short side. So if I was given the short side, I can find all the other ones. And it's easy to. If I have x, remember the medium side was just x times square root of 3. So where's my medium side on here? Well, here's my 90 degrees. Opposite the 90 is the big side. So the m must be the hypotenuse, the big side. That means my medium side would be opposite the n, which ends up being, or the medium side would be opposite the 60 degrees, which ends up being the n. So here's 60 degrees. This would be my medium side, n. The medium side is the short side times square root of 3. So n is the short side. There's my short side, times the square root of 3. Square root of 3 times square root of 3 makes the square root go away. So we just get 3. So n is equal to 6 times 3, which means n is 18. And now for the hypotenuse, remember the hypotenuse is just the short side times 2. So for m, it's going to be equal to the short side times 2. 6 times 2 is 12. I don't want to multiply into the square root here. That's a separate operation. So m is equal to 12 times the square root of 3. And you can just leave it right like that. Keep things in simplified radical form. It's just nicer that way. So n is 18. N is 12 times square root of 3. So far we've taken a look at a problem where I've given you the hypotenuse, and now we've taken a look at a problem where I give you the short side. Let's look at what happens when I give you the long side, or the medium side. So this problem so this is 60 degrees, 30 degrees, 90 degrees. I'm giving you the medium side. So opposite the 60 here, we've got 5 times the square root of 3. This will be B, and this will be A. We want to figure those out. All right, well, I gave you the medium side. And we know how the medium side relates to the short side. Medium side relates to the short side because it's just multiplied by the square root of 3 from the short side. So if I want to go backwards, like originally we had the short side, we multiplied by square root of 3 to get the medium. Go backwards. We'll take the medium side, we'll divide by the square root of 3 to get back to the small side. So B will be equal to the medium side divided by the square root of 3. Square root of 3's cancel, and we're left with the short side being 5. Now, hey, we know the short side. Short side to hypotenuse is very easy for these. You just double it. So the hypotenuse, A, is going to be 5 doubled. So it's 10. Now, if you weren't sure how to do those, if you didn't remember this quite as well, this method of dividing and stuff, we can always fall back on our ratios as well. Let's see if we can write a ratio to go from the medium side to the hypotenuse. Let's see if we can do that. So I'll start with my medium side. That's 5 times the square root of 3, and I'll divide that by the hypotenuse that I want, A. I'll set that equal to the same ratio on the triangle that I should have kind of memorized. So my medium side over here is x times the square root of 3, and my hypotenuse over here is 2x. Once again, my x's are going to cancel. Bye-bye. They cancel out. X over x is 1. I want to get a all alone. So I'm going to cross multiply things here. 2 times 5 times square root of 3 is just 10 times the square root of 3. And a times the square root of 3 is just a times the square root of 3. Get this stuff away from the a. So get rid of the times square root of 3 by dividing by square root of 3. They cancel out, and we're left with the same thing that we had before. So you see, we can use our ratios to our advantage. And ratios are very, very nice because I'm telling you, this sort of thing, root 3 over 2, it comes up quite a bit. Or 2 over root 3, which we simplify to 2 times root 3 over 3. These numbers, they're going to come up quite a bit when we start doing our sine, cosine, and tangent stuff. So you'll want some of them kind of just memorized, okay? But we'll get to that when we get to it. For now, I want these triangles kind of memorized and understood. So if you have any questions about this lesson today, please send me an email. Again, tomorrow, you're going to get this worksheet. It'll be due probably by the end of the week. I don't think it'll take you terribly long if you follow along with this fairly well. And again, jump into any of my Zoom meetings and we can cover anything else that you need to, and we can go over whatever examples you'd like. Have a good one, guys.